Module 8, Investigation 4, Applying Trigonometry to Non-Right Triangles. Surveyors were interested in determining the approximate size of the lake shown below, so they set up their instruments in 3 different locations and measured the angles created. They were also able to directly measure the distance between Surveyor A and Surveyor B as shown. The triangle created is not a right triangle. However, we can apply the techniques of right triangle trigonometry by forming right triangles out of a given triangle. Draw a diagram below to show a few different ways that this is possible. Okay, to make a right triangle, we could start at this vertex and come down so that we form 2 right triangles here. We could start with this vertex and come to the opposite side. Make sure we get 90 degrees. These lines have to be perpendicular. Then we have 2 right triangles. Or we could come from Surveyor A to a point about right here. And then we have 2 right triangles. The lines you drew in Part A to create right triangles are called altitudes. Lines drawn from a vertex of a triangle perpendicular to the opposite side. Which altitudes will create a diagram that allows us to apply right angle trigonometry techniques to solve for the lengths of the remaining sides of the triangle? Defend your choice. Personally, I think that any of them would. I prefer one like this, just because it's easier for me to look at. But there's actually a problem with using this altitude, is that it splits the side that we know what it is up into 2 parts, and we won't know how long each side of those pieces are. So if we want to use this 1,472 feet, we're going to have to pick a different altitude. So, like for example, if we use this one, now in this bottom right triangle we have this long piece, this long side that we know, and we have these 2 angles that we know. Well, this one's 61. This one won't be 46 because we've cut that 46 degree angle in pieces. So now we know that this one is 90 minus 61, or 180 minus 90 minus 61, which is 29 degrees. And then that means that this angle here is 46 minus 29, or 17 degrees. So now we can use the sine and cosine and tangent and things to find these opposite sides. Find the distance from Surveyor A to Surveyor C and from Surveyor B to Surveyor C. So let's try this. Using our bottom triangle, look what happens if I take the sine of 29 degrees. That will be this opposite side right here. Let's just call it x for the moment, divided by the hypotenuse, 1,472. That means that 1,472 times sine of 29 degrees equals x. This comes out to 713.64 feet. Now let's find this piece of the triangle. I'll call it y. We can find that with the Pythagorean theorem. X squared plus y squared will equal 1,472 squared. So y squared equals 1,472 squared minus x squared. That means y is equal to the square root of 1,472 squared minus x squared, and x is 713.64. And that's 1,287.44 feet. Now looking at this triangle, I could say take the sine of 17 degrees, and that would equal this little piece, let's call it z. Actually, we don't know the hypotenuse, so sine wouldn't be a good choice. We could take the tangent of 17 degrees. That would be opposite over adjacent, so it would be z over 1287.44. That means z, we just multiply both sides by 1287.44, tangent of 17. .449821 feet, which seems totally not correct because I forgot the decimal point. Okay, actually got 393.61 feet. Equals z. So now we know the distance from surveyor A to C is 713.64 plus 391.61, get 1107.25 feet. Okay, so we still need the distance from surveyor B to C. So now all we need to do is use the Pythagorean theorem. With this triangle here, let's call this side W. That's the hypotenuse, so y squared plus z squared equals w squared. So w will equal the square root of y squared plus z squared, and that is the square root of 391, I'm sorry, y, I should keep this in order, that's 1287.44 squared plus 391.61 squared. Get about 1,346 feet. And that's the distance between surveyor B and surveyor C. Two ships have each determined their distance from a lighthouse on the shore. An observer at the lighthouse determines the angle between the ships. Determine the distance between the ships. Okay. So I want to make some right triangles somehow. Let's think about how to do that. Well, I want to keep this 48.5 degree angle. I don't want to break it up like this. I think we could probably either use this configuration or this one. It does break up one of our known sides, but we have another side that we know. I'm going to try this. So there are my two right triangles. So, let's see, this angle will be 90 minus 48.5, which is 41.5. degrees. Let's see, so let's find this side. Let's call it x. We know that cosine of 48.5 degrees equals the adjacent x over the hypotenuse 1.71. Notice that I picked cosine because I knew this angle and I knew that I had the adjacent and the hypotenuse. I could have picked sine of 41.5 and used the opposite over the hypotenuse. But anyways, this means x is equal to, if we multiply both sides by 1.71, cosine of 48.5 times 1.71. And we get 1.13308 miles. Now, we know that 2.65 miles is all the way across, and that means that this little piece over here will be 2.65 miles minus 1.3308 miles. .51692. So this side, this little piece over here is 1.51692 miles. Okay, let's also find this red altitude. Let's use the sine 48.5 degrees will equal this altitude. We can call it y over the hypotenuse 1.71, which means y equals 1.71 sine of 48.5. Okay, now we have enough information to find the distance between the two ships, because we now know the two sides of this right triangle. So let's call this distance d. Then we'll have d squared, which is our hypotenuse, will equal 1.28071 squared plus 1.51692 squared, which means that d will equal the square root of those numbers squared. That's miles. Find the length of the Sides and the missing angle measures in the following triangles. Okay, so I'm taking a look at this one here, and I'm thinking we should draw this line so we make a perpendicular. This is too tiny, but let's just pretend that this one is perpendicular right here. Actually, I don't think it is. I think we have to go outside of the triangle to get a perpendicular line. And that doesn't seem good. Let's just use this angle. There we have our two right triangles. One here and one over here. Those are my 90-degree angles. One thing we could find is this angle right here. We know that if we start with the largest triangle we had, 180 minus 30 minus 111, will give us this angle right here. And that's 39 degrees. Now that I have an angle in this triangle here, I can find this side length right here and this one right here, which then I can use to find all the other missing pieces. So I'm just going to start with sine of theta. That will equal this height here, or altitude, divided by the hypotenuse, 16.3. So the altitude is 16.3 times sine of theta, and of course I was using 39 degrees for theta. Okay, so this piece is 10.2579, and now I can use that to find this one, which I'll call x, because we know x squared plus h squared is 16.3 squared, and so x is the square root of 16.3 squared minus h squared, and h is of course 10.2579, and we get 12.6675 centimeters for x. Alright, so now coming to this triangle, I could find this length. Could I find that length? I believe so. We could use the tangent of 30 degrees equals the opposite, which is h, over this piece we'll call y. So y equals h divided by tangent 30, and h is the 10.2579. So y is 17.762 centimeters. That means that we can now find this length all the way across the AC, and that simply x plus y so AC is about 30.4 centimeters. The last thing we need to find is AB, then we'll have found all the missing sides and missing angles of our original triangle. So this one, we could do just about anything now. I'm going to use sine of 30. That equals h over AB. That means AB equals h over sine of 30. And h is 10.2579. And I got 20.5158 centimeters. So that's it for that first triangle. Now I'm going to delete all this to make room for the second. Okay, let's see what we have here. I'm going to just try dividing up my triangle like so. Well, yeah, let's do this. Let's do it like this. And we need to find lots of things. This side, and then we need to find these two angles, A and B. Well, first thing we can do is find this height. This altitude, we'll call it H. Note that sine of 35 degrees will equal H over 8.42. That means that H is equal to 8.42 sine of 35. Okay, I got 4.82951 inches for H. Now let's find this piece of the triangle. We could do that, let's say, like this. Cosine of 35 equals, let's call it x, over 8.42, or really just 8.42 times cosine of 35 equals x. Okay, so now we can find this piece y. We know that y just equals 11.25 minus 6.89726. So y is about 4.3 inches. Is that right? I think so. Okay, so now we can find AB with the Pythagorean theorem. AB squared will equal y squared plus h squared, which means AB will equal the square root of y squared plus h squared. Y is again 4.35 and h is 4.82. So AB is about 6.5 inches. Now we're still missing these angles B and A. Let's find angle A. Notice that tangent of angle A, really tangent of the measure of angle A, we'll just use A, equals the opposite over the adjacent. That means that A is equal to the inverse tangent of the opposite over adjacent. And that's 48 degrees. And then angle B would just be 180 minus 48 minus 35. Or 97 degrees. Now we found everything about that triangle. Find the area of this triangle. So we know the area will be 1/2 the base times the altitude. So let's see, maybe we could put the altitude right here. Or I think even easier would be to put it right here, I hope. This way we have a base of 15 centimeters. No, that's still kind of not very easy. I'm trying to find the one with the least amount of steps as possible. I think this will be just as good as any, and it'll be the easiest to look at. So first thing we need to do is find the altitude h. Notice if this is the altitude, then the base is AB. So this is going to be 1/2 whatever AB is, the length of AB, times h. Now h we can find because the sine of 77 equals h over 15, meaning h is just 15 sine of 77. So h is 14.6 centimeters. That means that I'm almost got my area. It's 1/2 times AB times 14.6, so 7.3 centimeters times the length of AB should give me my area. So now how do I find AB? Well, we're gonna have to find this piece. Let's call it, actually we could put just a point D here. We need to find AD and DB and add those together. Notice that cosine of 77 would equal AD over 15, so AD would equal 15 cosine of 77. And DB, let's see, well, the tangent of 48 would equal h over dB, so that means that dB equals h over tangent 48. So AB is simply AD plus DB, which is 15 cosine of 77 degrees, plus h over tangent 48. And we know h is 14.6. So I'm going to replace this h with 14.6. I'm going to put that in my calculator. Got 19.6 centimeters. Multiplying those together will give me the area, which is about 143 centimeters squared.